Welcome everybody. We've been given this question 5 positive 2x divided by x negative 1 is greater than 1. Now we need to be a little bit careful in solving this inequality. Okay, so most of the time what people would do is they would try to multiply both sides by x negative 1 so that this can be removed. But we cannot do that. Why? Because we do not know x, whether x is positive or negative. That information is not given to us. We are just given this. So in cases like this, where we are not sure if x is greater than 1 or x is less than 1, we cannot multiply both sides by x negative 1. Because of the fact whenever we multiply by a negative quantity, this inequality will get reversed. So we need to be cautious. So in the situation like that, how are we going to handle this question? So foremost, what I wish to do is I would actually add negative on both sides. Now adding is allowed. We are not doing any harm while adding or deducting, right? So in this case I add negative on both sides. So that would give me 5 positive 2x divided by x negative 1. I'm adding positive of negative 1 both sides. So this can be rewritten as 5 positive 2x divided by x negative 1, negative 1. Positive 1, negative 1, they get neutralized, giving me greater than 0. Now we can take the LCM as x negative 1. So this would be a 5 positive 2x negative of x negative 1 greater than 0. I can rewrite this as 5 positive 2x negative x positive 1 divided by x negative 1 greater than 0. I can add these two together and these two together. This would give me 6 followed by positive x divided by x negative 1 greater than 0. Now clearly for this inequality to hold good, x cannot be equal to 1. That is one situation. And the next situation is x cannot be equal to negative 6. Why? If I were to get x to be equal to negative 6, you will have 6 negative 6, which means 0 greater than 0. That's a contradiction. So we need to avoid that. Let me draw the number line now. This point is 0. This is 1, 2, 3. This is negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Okay, so these are the 2 points. Negative 6, x cannot be negative 6, and x cannot be equal to 1. Now after negative 6 comes x is equal to negative 7. So substitute that value and check if the inequality is satisfied. So let me take x to be equal to negative 7. 6 negative 7 divided by negative 7 negative 1. Okay, should be greater than 0. 6 negative 7 is negative 1. Negative 7 negative 1 gives me negative 8. And you have two negatives, they can become positive. So 1 over 8 is greater than 0. Is it true or false? It is definitely true. So if I were to draw a demarcation line, all values beyond this seems to be holding good. Fine. Now what I wish to do, I would like to draw a demarcation line here and check for values on this side. Okay, so let me go to the new side. So x is equal to 2. X cannot be equal to 1, right? X cannot be equal to 1 here, but I'm taking x is equal to 2. So 6 positive x over x negative 1 should be greater than 0 for x is equal to 2. So let me check that value and see. So 6 positive 2 divided by 2 negative 1 greater than 0. This is 8 over 1 greater than 0. This means 8 is greater than 0. Clearly this is true. So all values on this side is also holding good. Now let me check for values x equal to negative 2. And you have 6 positive x divided by x negative 1. We need to have this inequality greater than 0. So you have 6 negative 2 divided by negative 2 negative 1 should be greater than 0. This means 4 over negative 2 negative 1, that's negative 3. Now what is this? This is negative 4 over 3. Is it greater than 0? No, this is a contradiction. So that means none of the values of x that is falling in between -6 and 1 should be included in our solution set. So the solution is collection of all x such that x is element of from -6, right, from this end. -6 is not included, right? But all the way starting from -6, because if I were to take x is equal to negative, say, let me take say -6.2. Okay, this is not 6, but it's closer to 6. Let me show you the value there. So I want to check for the value x is equal to -6.2. So it's going to be 6 positive of -6.2. So -6.2 -1. This is going to give me -0.2. This is going to give me -7.2 greater than 0. Is it not? It's truly greater than 0. So when we are including it, we are taking the open interval, right? Collection of all x from -6 all the way to -infinity, union, as I mentioned to you, we are not including 1, but all the way to positive infinity. Okay, so this should be the solution set. But that's not what I'm saying. You cannot outrightly simply give the values. Okay, for all x, you cannot do this. For all x lesser than -6, outrightly you cannot give this, specify the values alone. You have to include them like this. So this will be the solution for this inequality. 5 it's 5 positive 2x is the original solution. 5 positive 2x divided by x -1 greater than 1. This is the original inequality. So having given you this, kindly subscribe and like and share until we meet again. Thank you.